Okay, let's start this transformation of functions lesson by looking at the graphing calculator. So if you take that out, and let's substitute in there absolute value, so math num absolute value of x, and then down in y2, let's make that absolute value, so math num of x, and then go beyond the absolute value, and let's do plus 2. And I'm going to go to zoom 6, or hopefully you have a standard window. And you should notice that it raises up 2. So that's a transformation of functions from the absolute value. And if I now go in and type math num absolute value of x minus 2 and hit graph, we should see one that's going down 2. However, if I change that and I go inside the absolute value and I do plus 2 and I delete the plus 2 on the outside and I graph that, we should see that moving to the left. So it's kind of the opposite of what we would think. I would have thought that plus 2 would go to the right, but plus 2 goes, I'm going to move this over a little bit. Plus 2 goes to the left. And if I change that in there to minus and graph that, there's absolute value, that one goes to the right. So it's a little bit opposite of what you'd think, kind of similar to when you graphed circles. And then if I go back to y equals and I do second, nope, I'm going to leave that one alone. I'm going to go down to the next one and do second insert, and I'm going to place a number in front of that, like 2. I'm going to go inside the absolute value and I'm going to delete the minus 2. So when we graph that one, it gets skinnier. It's called a vertical stretch. You take the, if you look at the table, you take the y-coordinates and they all get multiplied by 2. Hopefully you can see that. The x-coordinates are the same. y1 represents the y-coordinates on the absolute value of x. y2 represents the absolute value of 2 times the absolute value of x. Now if I change that number in front of there to 1/2, so if I do 0.5, and I delete the 2, oops, didn't mean to do that. So math num x, delete that, and then hit graph. There's the absolute value of x. Ooh, when we do the 1/2 of the absolute value of x, it gets wider, and that's called a vertical shrink. Okay? So one other one to look at, when I take and I put a negative and I delete that decimal in front of my absolute value of x, the first one graphs as usual, and the next one is a reflection over that x-axis. So then I can apply these to my notes. So if I have y equals absolute value of x, that was just here. Oh, hold on. Okay. So if I draw that, and then if I want to do plus 2, it's going to go up here. And the minus 2 went down 2. So we should say that this one goes up k and this one went down k, the amount, exactly as we thought it would. That is a translation slide of over 0, up or down k. You can write that as capital T subscript 0 comma k. That's your conclusion. The other one, we noticed that when we did 8x minus 2, it went 2 to the right. So here's absolute value of x. And if I change and if I go 2 to the right, different color. And then if I did plus 2, that went 2 to the left. Okay, so for that one, we would say it's the opposite. This one goes to the right, h, and this one goes to the left, h. And this is another translation of an amount left or right, up 0. So that we would say is capital T, h, comma, 0. And that depends on if h is positive or negative. All right, and then remember, okay, so that's really what's going on. All right, on the next one, it was that reflection over the x-axis. So here's absolute value of x, and here was the negative absolute value of x. Okay, so this is just really a reflection over the x-axis, and to indicate that we use a lowercase r and subscript x-axis. Okay, so a little bit of describe. x squared. Then we're going to move to the right. So this one is going to go to the right, opposite. So like that. So that would be maybe like x minus 2 squared, and then we're going to go to the left. And that one would be like x plus 2 squared. So this one goes to the left, h. And this one, our conclusion was, it was a translation of h comma 0, left to right, up 0. And then for the next one, y equals x squared. Left 3. And then this one is going to multiply the y coordinates by 3, which is going to be a stretch, get a little steeper. This one is going to multiply the y coordinates by 1/3, and it's going to be like a little shrink. Okay, next page is kind of another example here of how we would solve an absolute value equation or an inequality using a graph. So it's just a little review here. What you need to do is to graph this. So what I'm going to do is put into y1 absolute value of 2x plus 1, and figure out the points for that. So go back to y equals, clear this out, clear that one out. Okay, so math num, absolute value of 2x plus 1, and zoom 6. All right, so it might look like the minimum's at 0, 0, but I don't think it is. So when you go to your table, we want to look for that rainbow effect, and I think I need to kind of go up here to see it. All right, there we go. So you can see the 5s match, the 3s match, the 1s match. I think the minimum is between there. You need to have a y coordinate that doesn't repeat. All the rest of them will, but that will be your minimum, is the one that doesn't repeat. So there's my table of values, and we'll find the minimum. So remember, to find the minimum, we can go second, trace, choice 3. And I didn't want to do that. Second, trace, choice 3. There we go. Now I want the cursor to be to the left because it says left bound. And then I hit enter. And then I want the cursor to be to the right because it says right bound. And then I want it on it, and I hit enter. And so remember, that is -0.5, and this little 3 decimal point e negative 6 just means 0. You can check that out by going to second trace value and plugging in negative 0.5, and it should tell you then y is 0. So that's my minimum. So it is negative 0.5 comma 0. So in my table of values to graph this, I'd have negative 3, 5, negative 2, 3, negative 1, 1, and then I'd have 0, 1, 1, 3, and 2, 5. But that minimum has to be in here. It was negative 0.5, 0. You've got to have that. So now I'm ready to graph it. Okay, so there we go. Now I'm going to put into y1 absolute value. I already have that. Then I'm going to do y2 equals 5. And that's right here. So on the graph here, I really don't need the graphing calculator, but if you want the graphing calculator, you can do second trace intersect, because we're looking for these intersection points. We want those x coordinates. What are they? So when you go to second trace intersect, you move the cursor close to an intersection, and then you hit enter 3 times. And then you repeat for the other intersection. Okay, so I'm going to go and type in y equals y2 is 5, second trace number 5, and I'm going to just kind of move the cursor close and enter, enter, enter. 2, 5. Second trace intersect again. Oh, I want to do that again. I keep hitting enter. Second trace 5. I want to move that cursor over to the other intersection and then hit enter, enter, enter. I don't have to move left, right, and all that. So negative 3 and 2 are my points that I want. So this is 3 and this is negative 3. I was wrong. This is not 3. That's, I believe, 2. And we can see that it's 2, 5 and negative. So where is it below? Right here. This is where it's below the line y equals 5. You see how that's connected? So that answer, using the intersections, is -3 is less than x is less than 2. We've already solved this algebraically. Now we